Good evening, everybody. Welcome to the Global Frailty Network Frailty Seminar Series. My name is Dr. Carmen Castillo. I'm a geriatrician in Hospital Virgen del Valle in Toledo, Spain. And our speaker today is Dr. Emanuele Marzetti. But before introducing him, I'm going to take care of some housekeeping issues. I would like first to remind you about the Global Frailty Network, which is a group of healthcare professionals and researchers dedicated to frailty that started the Frailty Seminar Series in 2021 with the purpose of exchanging and sharing evidence-based practices and research advances about all aspects of frailty. The Frailty Seminar Series 2023-24 will present a lineup of renowned speakers from around the world, sharing their expertise in the rapidly growing field of frailty. At the end of this talk, we'll have a few minutes for questions and answers. You can write your questions in the chat, which is in the bottom right of your screen, and Dr. Marzetti will answer them. And if you are a clinician practicing in the USA or Canada, you can claim AMA PRA credits, and you will receive the instructions at the end of the webinar. And I'm going to introduce Dr. Marzetti, who's going to talk about biomarkers of frailty and sarcopenia. Emanuele Marzetti is a board-certified geriatrician, associate professor of internal medicine and geriatrics in the Department of Geriatrics and Orthopedics at the Università Cattolica de Sacro, Rome, Italy, and the director of Orthogeriatric Unit of the Fondazione Policlinico Universitario Agostino Gemelli, IRCCS, Rome, Italy. He has long-standing clinical and research experience in the fields of frailty, sarcopenia, and other disabling conditions. Dr. Marzetti has authored or co-authored over 400 scientific publications on topics related to the pathophysiology of skeletal muscle and cardiovascular aging, frailty, sarcopenia, and biomarkers for complex age-related conditions. He has acted as the PI or co-PI for national and international research projects focused on major age-related conditions.
And good evening, everybody from Rome. It is 6 p.m. And tonight we're going to talk briefly about our research on biomarkers for frailty and sarcopenia. This is my conflict of interest disclosure, but I can tell you that none of these entities is in the position of influencing any content of my talk. Biomarker, okay, everybody knows what a biomarker is, but just as a refreshment, a biomarker is an objective characteristic that is measurable as an indicator of a normal biological process, of a pathogenic process or response to an intervention or an exposure, including therapeutic interventions. This is the FDA NIH Biomarker Working Group definition of a biomarker. Every healthcare professional is very familiar with biomarkers because we use them on a daily basis for doing our job. We use them, for instance, to assess the susceptibility of developing a condition, for instance, in a response to an exposure in an apparently healthy person. We use them to detect or confirm the presence of a disease, for instance, blood sugar for diabetes, to monitor the status of a disease or the effect of an intervention, for prognostication purposes, to identify the likelihood of a clinical event, a disease, or progression of a disease, to predict which individuals are more likely to experience a favorable or unfavorable effect from a specific intervention, and to monitor, to appreciate the response to a specific intervention or an exposure. When we move our attention to the field of frailty and sarcopenia and we focus on biological markers, this is the situation we are in. There are actually no reliable or clinically meaningful biological markers for either frailty or sarcopenia. And why is that? First of all, I think this is the major problem we're facing now. There are multiple and only partially overlapping operational definitions of both frailty and sarcopenia. Everybody agrees on the theoretical construct of the two conditions, but as you know, there are many different operational definitions, and the agreement among them is at best moderate. The two conditions are also complex and multifactorial. Their pathogenesis is not completely known. There are probably multiple biological mechanisms that are simultaneously involved in the development and progression of frailty and sarcopenia, which means that possibly multiple biomarkers may be needed to fully frame the two conditions. Frailty and sarcopenia usually develop over years, and pathogenic process may not be necessarily the same during their whole course, which implies that different biomarkers may be needed depending on the disease stage. This is just to give you an example of what the problem is, that we have multiple operational definitions of frailty. This is a study from a few years ago from a very outstanding group of researchers in the frailty field. They analyzed the SHARE database, a cohort study conducted in Europe, and depending on the definition applied to assess frailty, the prevalence rate of the condition ranges between 6% and 44%. And this is obviously a problem, because you cannot develop a biomarker if you do not know whether a person has the condition or not. And the situation is possibly even worse for sarcopenia, where we not only do we have a multiple operational definition of the conditions, but we also have different ways to assess the same parameter. Just think of muscle mass. That you can assess or estimate actually muscle mass using anthropometry, BIA, DEXA, CT scan, MRI, and so on. And the same applies to muscle strength or physical function. Also, in this case, we have different tools to measure these parameters, and different cut points depending on the operational definition considered. And again, you cannot develop a biomarker if you do not know if the person has sarcopenia or not. To shed some light in this complex field, we designed the Biosphere study some years ago. We took advantage from the definition of physical frailty and sarcopenia that was operationalized by the SPRINT consortium, where we identified a biological substratum of physical frailty, which is muscle atrophy, an acceptable method to measure physical function impairment, which is the SPPB, and a clear clinical phenotype characterized by poor balance, slow walking speed, and muscle weakness. For the definition of physical frailty and sarcopenia, we used the cut points for appendicular limb mass released by FNIH, because at the time the study was designed, they were the only data-driven cut points of muscle, or actually appendicular limb mass. And for the SPPB score range, we focused on scores between 3 and 9, because we were interested in operationalizing a pre-disability condition that would be amenable for preventive interventions against disability. And the clinical trial that was designed based on this operationalization of physical frailty and sarcopenia was successful. We showed that mobility disability could be somewhat, to some extent, prevented by a multi-component intervention involving physical activity with technological support and nutritional counseling. We showed that the multi-component intervention reduced the risk of incident mobility disability by approximately 22% over a maximum follow-up of 3 years. And the effect of intervention were consistent across sexes, races, age groups, history of cardiovascular disease, diabetes, and gait speed categories. So going back to Biosphere. Biosphere was designed as a case-controlled study to develop and validate a biomarker discovery strategy for physical frailty and sarcopenia through the use of multivariate methodologies as an alternative approach to the single marker approach that was very typical at the time we designed the Biosphere study. These are the general characteristics of the population of our participants. Older adults with physical frailty and sarcopenia were a little older than a non-sarcopenic, non-frail controls. The BMI was higher in the PFNS group compared with controls. Obviously, SPPB summary score, appendicularly mass, either absolute or adjusted by BMI, was lower in the PFNS group compared with controls. But the number of disease conditions and the number of medications were comparable between groups. There were no differences between cases and controls. For the analysis of data, of biomarker data, we relied mostly on chemometrics because these methodologies are very suitable for handling correlated multi-platform variables, and we chose tests that were most suitable for identifying biomarker patterns within a large number of analytes obtained in a relatively small number of participants. We also applied cross-validation procedures to make sure that findings were not simply attributable to chance correlations. The scientific rationale underlying our biomarker study was inspired by the geroscience paradigm. Geroscience is a new field, relatively new field of research that aims at understanding how the fundamental biological mechanism of aging intervene in the development and progression of most chronic degenerative diseases. And with our biomarker discovery strategies, we try to target as many hallmarks of aging as possible. These are the first paper by Lopez-Sotin groups in 2013, and this is the update with some new hallmarks of aging last year. For the rationale of our multi-marker strategy was inspired by the TAME biomarker work group, who recommended the use of multiple markers to assess multiple biological processes of aging. Why we adopted a geroscience-based approach? Because physical frailty and sarcopenia is a prototypical geroscience condition with a complex pathogenesis involving muscle-specific and non-muscle-specific processes. The former, for instance, include mitochondrial dysfunction, redox imbalance, protein dyshomeostasis, acceleration of myonuclear apoptosis, deregulation of autophagy, aberrant remodeling of neuromuscular junctions, and iron dyshomeostasis. Non-muscle-specific processes that are possibly involved in the pathogenesis of physical frailty and sarcopenia include systemic inflammation, hormonal changes, telomere shortening, malnutrition, and gut dysbiosis. So starting from this background, we try to, as I told you, adopt a multi-marker approach and to measure a panel of biomarkers in our participant sample. This is the first study that was published in 2018, where we measured a panel of 37 amino acids and derivatives using mass spectrometry. Then we applied a PLSDA statistical approach to discriminate between cases and controls based on amino acid concentrations in serum. And we obtained a very nice separation between older adults with physical frailty and sarcopenia and controls using only 9 amino acids out of 37 that were measured, with a rate of correct classification in the total sample of over 75%. Next, we were, of course, interested in systemic inflammation. And we measured a panel of 27 inflammatory biomolecules in serum of our participants. And we identified what we called the frailty cytokinome, which was composed by myeloperoxidase, PDGF-BB, interleukin-8, MCP1, and CRP. There were different in participants with physical frailty and sarcopenia from controls regardless of sex. And also we identified some sex-specific signatures. And also in this case, the rate of correct classification was above 75%. In this other study, we tried to merge all the mediators that were measured in our previous studies, plus we added some additional candidate biomarker, such as C-reactive protein, FGF21, BDNF, and CAF, which is the C-terminal actin fragment, is supposed to be a marker of neuromuscular junction disruption, and P-selectin, each of protein 72, IGF-1, and so on. And so we had, in this case, the problem of analyzing mediators coming from different platforms. So for the data analysis, we relied on a multi-block data fusion method, which is called sequential and orthogonalized covariance selection, in brief, SOCOVSEL, which is a very reliable classification method, which also allows to identify among a large number of mediators those that are truly important for discriminating between the categories of interest, in our case, physical frailty and sarcopenia, and controls. And starting from a total of 74 biomolecules, we ended up with 7 candidate biomarkers that were able to discriminate participants with PFNS from controls with a rate of correct classification of over 80%. The mediators that were identified were biologically plausible, and because they are involved in inflammation, nitrogen and glucose and glutamine, metabolism, oxidative stress, and stress response. So all processes that are biologically plausible as putative mechanism of physical frailty and sarcopenia. We were also interested in understanding whether gut microbiota could be different between participants with physical frailty, sarcopenia, and controls. So we conducted this other study where we measured, where we characterized the gut microbiota in a subsample of participants for whom fecal samples were available. And we obtained a striking rate of correct classification of 90% using one inflammatory mediator, one amino acid, 2 amino acids, and 4 bacterial taxa that were different between cases and controls. Mitochondrial dysfunction is probably the most actively studied process in muscle aging. Mitochondria, as you know, are not only energy suppliers, but they are involved in a multitude of processes relevant to muscle physiology, including myonuclear apoptosis, redox balance, the balance between proteolysis and protein synthesis, and so on. So these organs are truly crucial to muscle health. The problem is that if you want to access muscle mitochondria, you need to take about a muscle biopsy, which is not easily doable in frail, sarcopenic, multimorbid older adults. But thankfully, there is another way to obtain indication on mitochondrial health with a mini invasive procedure, just a blood draw. because mitochondria that are mildly oxidized they are not necessarily destroyed completely by mitophagy, but they can undergo a process called is a mitochondrial quality control process that ends up with the release in the circulation of extracellular vesicles containing mitochondrial particles. And these vesicles can be isolated from biofluids, such as blood, for instance, and characterized for their origin and content. And that's what we did in this other study, where we, from serum, we isolated small extracellular vesicles from participants with physical frailty and sarcopenia and controls. We made sure that we isolated what we wanted to isolate using electron microscopy. These arrows indicate extracellular vesicles. And then we measure their concentration in the blood, finding that their quantity was higher in older adults with physical frailty and sarcopenia than in controls. And we measured some mitochondrial markers contained within these vesicles using an antibody mix against OXPHOS complexes. And we found that subunit of complex 5, complex 3, and complex 2 of the electron transport chain were less expressed in extracellular vesicles from participants with physical frailty and sarcopenia. We don't know exactly what this means. In other words, we don't know what the biological meaning is that in vesicles from older adults with physical frailty and sarcopenia there are a smaller content of mitochondrial particles. One possibility might be that the mitochondrial quality control process is stuck in these people, either the mitophagy path, both the mitophagy pathway and the extracellular vesicle pathway. And this is why mitochondrial particles are not so abundant in the presence of frailty and sarcopenia. But of course, more mechanistic studies are needed to understand what the biological meaning of this finding is. We also wanted to verify whether mitochondrial-derived vesicles isolated from the serum would be important in the discrimination between older adults with physical frailty and sarcopenia and controls. So we ran these additional studies where we measured, again, the panel of amino acids, the inflammatory panel, and the content specific content of extracellular vesicles. And we found that indeed the one subunit of complex 4 of the electron transport chain was among the biomolecules discriminating between cases and control, with a rate of correct classification of 80%. Cell senescence is another hot topic in geroscience. As you know, senescent cells are cells that have stopped dividing because they have divided too many times or because they have suffered some damage. But in some cases, these cells are not eliminated, and they persist as what is called zombie cells. And these zombie cells are actually harmful for the tissue, for the surrounding cells, the tissue, and the organism as a whole, because they secrete molecules that affect the physiology of other cells and the tissue. This is called senescent secretome, or SASP, senescence associated secretory phenotype. This is the rationale underlying the use of senolytics, for instance, to treat or to prevent or treat some diseases. We measured a SASP panel in our participants. We measured 10 biomolecules belonging to the SASP. We analyzed the relationship among these molecules in the two groups of participants. We found that these molecules were differently related to each other depending on the condition. But more importantly, we found that 5 out of the 10 SASP molecules that we measured were important for discriminating cases from controls with a rate of correct classification of 74% based on serum concentration of GFAP, ICAM1, TIMP1, IL-6, and TNF-alpha. So also this SASP is a source, a potential source of biomarkers for physical frailty and sarcopenia. We also took advantage of our involvement in MID-Frail. MID-Frail was a European study led by Professor Leocadio Rodriguez Mañas from Spain and Professor Alan Sinclair from the UK. The MID-Frail was a randomized clinical trial that evaluated the effectiveness of a multimodal intervention for preventing functional decline, improving quality of life, and reducing healthcare costs in frail or pre-frail adults 70 years or older. This is the general characteristics of the mid-frail population. The table is taken from the main article, the main study article that was published in the Journal of Access Sarcopenia and Muscle in 2019. As you can see, the population, total population was over 900, basically 50% men and 50% women. The mean age was 78 years. As expected, these people were either overweight or obese, and in 37.8% of the population was frail. The remaining, as I told you, was pre-frail. They had a fairly large number of comorbid conditions as expected in such a population. The primary outcome of mid-frail was an increase of the SPPB score equal or greater than the minimal clinical important difference for the test, which is 0.5 point. And the trial succeeded, showing that the multimodal intervention increased the SPPB score compared with the control group by 0.85 points, which is greater than 0.5, the minimum important difference for the SPPB. Metabofrail was designed as a sub-study of mid-frail to obtain information on possible biomarkers, diagnostic biomarkers and predictive biomarkers. For the metabofrail sub-study in our center, we enrolled an additional cohort of 50 older adults with no physical frailty and no sarcopenia. These are the general characteristics. These are the general characteristics of the control older adults. And we started to compare participants from metabofrail with controls and with older adults with physical frailty and sarcopenia. This is the first study that we published a few months ago, where we compared the amino acid profile in serum of these 3 categories of older adults. And interestingly, we found that the participants from mid-frail, which remind you were either pre-frail or frail according to the frailty phenotype and in the feed with type 2 diabetes, were completely different from both controls and older adults with physical frailty and sarcopenia. I'm not sure if you can see this the panel A. I can't see it, but let me try. We validated our results using double cross validation with permutation testing, and also using an additional classification test, which is called SIMCA. And also in this case, you can see that the participants with either pre-frailty or frailty and type 2 diabetes were completely different from controls and older adults with physical frailty and sarcopenia in terms of amino acid patterns in serum. The amino acids that were most involved in the discrimination among the three categories were 3-methylhistidine, alanine, aspartic acid, and glutamic acid, arginine, and taurine. Each of these amino acids has specific roles in physiological processes, so they are credible biomarkers to be tested in future studies. So to conclude, we showed with our studies that multivariate modeling of complementary biomarkers is a suitable strategy for capturing the complexity of a condition such as physical frailty and sarcopenia. We also show that biomarker profiles vary according to the phenotype of physical frailty considered. Mid-frail participants were completely different in terms of serum amino acid patterns compared with older adults with physical frailty and sarcopenia. The analytical approach used in Biosphere allowed identification of specific patterns of biomarkers pertaining to complementary physiological domains, and we are now planning and actually starting additional analysis to identify prognostic and predictive biomarkers of physical frailty and sarcopenia using our longitudinal cohort. Before concluding, I would like to thank all my collaborators, and especially Professor Anna Picca, Dr. Elio Cosequalo Jr., Dr. Riccardo Galvani, Professor Federico Marini, and Professor Flora Guerra for their constant work on this specific area of research in our department. And of course, I would like to thank all of you for your kind attention.
Thank you so much, Dr. Marzetti. Now we have a few minutes for questions. Just to remind our participants that they can write the questions in the chat, which is in the bottom right of the screen. I have a couple of questions for you, Dr. Marzetti, while we wait our participants to write their questions. What are the primary biomarkers that can reliably indicate the onset and progression of frailty in older adults?
Well, I can't answer this question because we don't have, we haven't completely analyzed longitudinal data. We have started with some experiments, but it takes time because first of all, you need to choose the most likely important biomarker among a big group of biomolecules. Of course, we can't measure them all because it would be too expensive and too time consuming. Based on our data, on our cross-sectional data, the most promising biomarkers seem to be inflammatory biomarkers and the SASP biomarkers.
Mm-hmm. And how do biomarkers of frailty differ from biomarkers of sarcopenia? And are there commonalities between the two conditions in terms of biomarkers?
Yeah, as I told you earlier, we adopted the definition of physical frailty and sarcopenia that was produced by the SPRING Consortium, where the two conditions are merged. So there are no differences between the two because sarcopenia is the biological substratum and frailty is the clinical output of muscle failure. But of course, depending on the operational definition you use, you will have completely different biomarkers. Just to give you an example, we ran a biomarker study several years ago using the first definition of operational definition of sarcopenia by the European Working Group. Meanwhile, the second definition, the updated definition, came out, and when we tried to use the same biomarkers in the same population, categorized according to the updated definition, we did not get any meaningful result. So the definition you use is very important. This is why I believe that agreement on the operational definition is crucial for identifying biomarkers, to design treatments and drugs.
Have one question here from Sofia Jaramillo. Have you done any evaluation of these biomarkers in adults with chronic comorbidities who are also frail?
Yeah, our participants were the typical older adults that we see on a daily basis in our patient clinic or in the world. They are multimorbid. They're very close to the typical older adult.
Another question from Namrata. Was a great talk. So much information that I might need to hear it a few times again. Can we please?
But yeah, the slides are available.
Anyway, it's recorded and you can see the globalfrailty.org webpage. Well, can we please have the recorded lecture? Yes, I just told you on the globalfrailty.org. Have another question for you. Can you explain the role of inflammatory biomarkers in assessing frailty and sarcopenia? And how do these inflammatory biomarkers correlate with muscle loss and functional decline?
Yeah, there are several biological pathways that are triggered by inflammation in muscle. The one pathway is proteolysis, for instance, although it seems that sarcopenia is not due to an increased in muscle breakdown, rather it seems to be more linked to a decrease in muscle anabolism, which is also influenced by inflammation through insulin sensitivity. You know that inflammation reduces insulin sensitivity, and insulin is an anabolic hormone. Another pathway that is triggered by inflammation is myonuclear apoptosis through TNF-alpha, which leads to activation of caspase 8 and caspase 3, and then the apoptosis of the myonucleus with the surrounding sarcoplasm. And inflammation can also trigger mitochondrial dysfunction by promoting mitochondrial depolarization. So there are, a bunch of possibilities.
I have a question from Leonardo. Excellent presentation, as always, from Professor Marzetti. Mitochondrial dysfunction is antagonistic hallmark. Is there any hallmark to discriminate the turning point from positive pattern to detrimental effect?
Regarding mitochondrial pathways or in general?
In general, I guess. I don't know.
Oh, probably. I think that Leonardo meant mitochondrial function because you're right. Mitochondria are involved in many pathways that are integral to cellular housekeeping. So there is not a clear discrimination between a good and a bad side of this pathway. For instance, autophagy, which is key to housekeeping, may induce muscle atrophy if it is too much. Oxidative stress is not necessarily bad because free radicals are important second messengers, and people who take antioxidants before doing exercise have some fewer gains in muscle mass and strength than those without antioxidant supplementation. I can't tell you, now whether there is a precise demarcation between a separation between a good side or bad side of mitochondrial pathways.
Question from Gerardo Cabanillas. Great talk about the mitochondrial-derived vesicles. Is there any study showing a reduction in the number of these vesicles in the bloodstream after an intervention program to improve frailty?
This is an excellent question. I hope I will be able to answer this question in a follow-up talk because there are no studies that have specifically focused on extracellular vesicles in frailty and with interventions. but we do have plans for doing this study. Actually, today I submitted a grant application to the Italian Ministry of Research to get some funding to conduct this research, because the research on extracellular vesicles is labor intensive and very expensive.
A question from Tanya. What advances in imaging technologies or techniques have improved the accuracy and efficacy of measuring muscle mass and strength as biomarkers?
Yeah, this is a very good question. I usually get upset when I hear experts in sarcopenia saying that muscle mass does not matter. The problem is not that muscle mass is not an important parameter. The problem is that we are not able to measure it accurately. That's the main problem. DEXA is not a gold standard for measuring muscle mass, because it measures lean mass, which is not only muscle. The gold standard would be CT or MRI, but they're very expensive. There are not cut points such as those we have for BIA, for instance, and DEXA. I think that the most accurate way to measure muscle mass is D3 creatine, but is limited to experimental settings. It's not available for a general user yet. Although, if you look at the studies using this method, you will be amazed by the accuracy and simplicity. The method is relatively simple.
Okay. Another question. Are there specific genetic biomarkers associated with a higher risk of developing frailty or sarcopenia? And if so, can this be used for early intervention? Genetic biomarkers.
This is another very good question. We did a GWAS study a few years ago to understand whether there were SNPs associated with a greater risk of functional decline. We found 2 SNPs, but when we tried to validate the 2 SNPs in an independent cohort, we failed. So my view is that there is not a single genetic variant that can be used as a marker of susceptibility to sarcopenia or frailty, because most of the 2 conditions depend on our lifestyle, diseases, and chance, probably.
Exactly. How do potential biomarkers change with age? And what is the significance of these age-related variations in assessing frailty and sarcopenia?
Yeah, in all our studies, we took age into account, because we were, of course, focusing on older adults, but the participant sample was between 70 and 90 plus years. I don't remember exactly what the upper limit was for age. So we took age into account in our models, and age was not associated with any of the biomarkers that we measured.
Can biomarkers help in tailoring personalized interventions for individuals at risk of frailty and sarcopenia, at least in the future? Do you think that will be possible?
Yeah,
how effective do you think this approach will be?
I think so. First, I think it is important to understand whether there are predictive biomarkers that can identify, for instance, in our study, we are focusing on biomarkers predictive of response to lifestyle interventions. Because also in sprint and in life, and in all studies on frail and sarcopenic older adults, there are responders and non-responders to the same intervention. So there must be something in responders and non-responders that can be identified to tailor the intervention. So the next step, once you have a biomarker panel that can distinguish between a person who's more likely to respond from a person who's more likely not to respond to intervention, then you can dig deeper and try to understand the biological pathways that are possibly responsible for a different response to intervention to tailor the intervention. This is probably a little far away.
Yeah.
I would be more than happy to find a biomarker panel that distinguishes responders from non-responders.
Exactly. I have a question from George, Solis George from Greece. Is there any known link between the age of mother at birth and the quality and quantity of mitochondria?
Not that I know, but we know, for instance, that the weight at birth is a factor.
The weight of the baby.
Yeah, the baby is a factor affecting the risk of developing sarcopenia. But I'm not sure, I mean, I'm not aware of it, whether there are differences in mitochondrial quality or quantity depending on mother's age.
Yeah.
This is an important question because, you know, in modern societies, women tend to have babies later than before. So this might be something interesting to, this worth investigating.
Yeah. An interesting question. What are the challenges in standardizing the use of biomarkers for frailty and sarcopenia across different healthcare settings and research studies?
The major problem, as I said earlier, is an agreement on the operational definitions, because if two studies use two different operational definitions for characterizing their population, you have a big problem right there. You cannot compare the two studies. You cannot standardize biomarkers. Another problem with biomarker studies, at least in our case, is that they are very expensive. So you need to be very clever when you choose your cohort and for the training and for the validation. So again, we have studies planned also to validate in external course our findings.
Okay. A question from Sofia Jaramillo. We know frailty is also present in younger adults. Could these biomarkers be used in the 30 and 50s age range?
I don't think we can use the same biomarkers because unless you have a very reliable biomarker of biological age, because that's what we need. But with biomarkers we are testing now, I don't think we can apply the same reasonings to younger people with frailty, because the people that develop frailty at a very young age are somewhat different from older adults.
And different pathways. And
yeah,
another question.
The pathways leading to frailty are very different in those people.
Could you discuss the ethical considerations of privacy concerns when collecting and using biomarker data in the context of frailty and sarcopenia research?
Privacy, is that what?
Yes. Like, I guess if you take a biomarker and you tell somebody that they are at high risk for frailty, is there any ethical consideration?
Well, now we don't have susceptibility biomarkers available, but I wish we could have it. And in case you have it, there are no ethical issues. If a person is at risk for a disease, you just need to tell the person that is a high risk of developing a certain outcome, and to try to understand why that person is a high risk, to try to deflect the trajectory of frailty. So I don't see any ethical issue. The ethical issue would be if you know that a person is at risk and you don't do anything.
Okay. But we can do something about it, so there will be no ethical problem.
Frailty.
Well, a question from Rola Thailand. Is there a cutoff age to start talking about frailty? Is it only in the gerontology context? I don't think so.
I didn't hear the question. Can you please repeat?
Is there a cutoff age to start talking about frailty?
No. We collaborated to a book on frailty, and one of the chapters of this book was frailty in infants and preschool kids, adolescents. The problem is it depends on what you mean by frailty. If we focus on physical frailty, that is probably something that is more related to older age. But frailty as a whole, as a risk condition, it's something that can be observed, unfortunately, at a young age as well.
Mm-hmm. Okay, so it was a wonderful discussion, Dr. Marzetti. Yeah. And I think that we're going to finish our seminar for today. Thank you, everybody, for participating in our webinar. And please join us on December 13th for our next webinar. Dr. Ariela Orcavi from Harvard University in the USA will present the webinar, an update in the VA Frailty Index, moving from big data to the clinic. And again, I remind you that if you are a clinician practicing in the USA or Canada, you can claim AMA PRA credits. You will receive instructions at the end of the webinar. Thank you so much, everybody.